Our lesson today can be found on page 46 in your notes booklet. We're going to talk today about intersection and union. Okay, and this is where you'll see the work that we've done on circle logic with the Venn diagrams will come into play. So we have three different sets that we're going to use as we talk about what intersection and union of sets is all about. That's set E, which consists of the elements 0, 2, 4, 6, 8. Set L, which consists of the elements 0, 1, 2, 3, 4, 5, 6. And set O, which consists of the elements 1, 3, 5. Okay, the first one we're going to talk about is intersection. And that is just like it sounds like on a Venn diagram, that is any elements that are a part of both sets where the two sets intersect. So any elements that would belong in this middle section on the Venn diagram. Okay? We say it is a set that is called A intersect B, and it's denoted, or the symbol for it looks like this. So this actually says A intersect B. And you can kind of remember that this is the symbol for intersect because it almost looks like a lowercase n for intersect. So where A intersects B, where those two circles on the Venn diagram intersect, what they have in common. Okay? So if we were going to display the relationship between the three sets that we were given right here, E, L, and O, on this Venn diagram, we would have to label one of our circles as E. And remember, it denotes a set, so it needs to be an uppercase E. This is set L, uppercase L. And we have to look and see which elements belong in the intersection of set E and set L. In other words, what elements are in both E and L. So 0 would be, 2 would be, 4 would be, and 6 would be. Okay, that leaves us with just 8 in set B alone only, and that leaves us with 1, 3, and 5 in set L only. Okay. So if we were going to use proper notation to write the intersection of sets E and L, we would write it like this. E intersect L equals the subset, or the set, 0, 2, 4, 6. Okay, that's all of the elements that would be in the section where set E intersects set L. Okay, now a union, on the other hand, is a little different. A union is of set A and B would be called A union B, and the symbol for it is A with kind of a stretched out U for union B, and it's the set of elements that are members of either set A or set B or both. Okay, just like we talked about when we were talking about the inclusive use of the word or. When we say or, we mean it's in this set or this set, or it could be an element of both. Okay, so you need to listen for kind of key words. When we're saying it's in this set and this set, we're talking about an intersection. That's the word and. When we're saying the word or, we're talking about a union. It's in this set or both. Okay, so we need to use appropriate notation to write the union of set E and set L. And we're not writing the same element more than once in the set. So if it's in both, we don't write it twice, in other words. Okay, so the way we would write that is E union L Okay, so this is the elements that would be in set E, or set L, or both. So in other words, it's all of those elements, isn't it? Okay, so we would write it as this. That would be the set of, and usually we write them in ascending order. So it would be 0, 1, 2, 3, 4, 5, 6, and 8. Okay, it's either in set E or set L or both. There is no 7 in these sets, is there? Okay, grab your highlighter and just highlight this next sentence here. Two sets are said to be disjoint if they have no elements in common. Kind of like that example we looked at about the Bug Cafe, where that salad set was a set all by itself because it didn't share any elements in common with any of the other foods that people were ordering in the diner. Okay, that's what we're talking about, a circle set apart all by itself because no elements in it are also elements in any other set. So it's called a disjoint set, which kind of makes sense. That term sounds like it's set apart, not with the other set. Okay, so let's have a look at this example. We're looking at sets A, B, C, where the universal set is natural numbers less than 20. Okay, remember this is universal. So in other words, that's the set that we're considering and taking all these numbers from. So the universal set is natural numbers less than 20. You guys remember what natural numbers means? Natural counting numbers, right? You can see for this unit, you're going to have to know natural numbers, whole numbers, real numbers, what they are, okay? Okay, counting numbers less than 20. So that would be all these numbers. If I were going to define the elements, that's 1, 2, 3, 4, on and on and on, and ending at, not 20, less than 20, so ending at 19, right? Okay, that is my universal set. Okay, then we have defined sets A, B, and C. So set A is natural numbers less than 20 that are divisible by 3. B is natural numbers less than 20 that are divisible by 5. And C is natural numbers less than 20 that are divisible by 6. So let's list the elements of each set. So set A is all the elements, natural numbers less than 20, divisible by 3. 3, 6, 9, 12, 15, 18. Does it include 20? 1? Nope, that would be the next number in this pattern, but that's not less than 20, so that's where we stop. Okay, set B, natural numbers less than 20 that are divisible by 5. That's just 5, 10, 15. Do I include 20? No, I do not. Okay. And set C, natural numbers less than 20 that are divisible by 6. 6, 12, 18, and that's as far as I can go. Okay, let's display each set using Venn diagrams. Okay, now this is a Venn diagram that involves 3 sets, so that's why we use 3 circles. We need to label one circle as A, one set as B, and one set as C, and then we're going to put the elements where they belong. Let's start first of all with any elements that would be in this middle section here. In other words, they would be an element of set A, and an element of set B, and an element of set C. What numbers should I put in that center section? Are there any elements that would be in all 3 sets? No, they're not. So nothing goes in that middle section. Okay, what about elements of set A and set B? Just the number 15. So it goes here. It's an element of set A and set B, but it's not an element of set C, so that's why it does not go there, right? Because that's part of circle C as well. Okay. What digits would be elements of set A and set C? 6 is 1. 12 is 1. 18 is 1. Good, I hope you got them. What digits are elements of both set B and set C? There are none. So what numbers would be elements of set A only? 3, yeah. 9, and that's all. Okay, what about set B only? 5 and 10. Yeah. And set C only? Right, none, because all the elements of set C are also elements of set A. In other words, set C is a subset of set A, isn't it? All of its elements are elements of set A. Okay, so let's use our Venn diagram then that we have created to answer the questions in C. Okay, number 1 says A, what is this symbol again? It looks like an N. Intersect, right, where A intersects B. Okay, what elements lie in the section here where A intersects B? That would be this whole area here. Oh, right, but if an element is in this section, it means it also intersects C. And that's not what this question is asking. It's asking just where A intersects just B. So just this part, not this part. Down here. Okay, so that would be just the element 15. Okay, what about A union B? Remember, union means it's in A, or it's in B, or it's in both. Union is or. Intersect is and. Maybe write those in the margin just so you remember. It's in A, or it's in B, or it's in both. And again, like I said, we always list it in ascending order. So it'd be the 3, 5, 6, 9. I want you to be looking for it up here yourself, not just copying what I'm copying. 3, 5, 6, 9, what else? 10, 12, yeah, 15, 18. Okay, so those are the elements that are in A, or in B, or in both. In other words, really, that's this whole area here, right? A or B or both. Okay, that's A union B. I'm going to just relabel my diagram again. Really quickly. Okay. Now we're looking for the elements that are in A prime intersect B. A prime. That means they're in the universal set, but they are not in A. Okay, so we disregard anything that is in A. So all that's left is 5 and 10. If you cover up A with your hand, put your hand right over top of A, it means nothing that is in A, right? So that's just 5 and 10, and it's where that intersects B. In other words, it is also in B. Well, 5 and 10 is also in B. Yeah. So that is just 5 and 10. Okay, the next one says where B intersects C. In B intersect C. The area where B intersects C, that's here. There's nothing there, not even a 0. Like nothing there. How do I write a set that is empty? There's nothing in it. Ah, that's the empty set. It is a set. It's the empty set. Okay. A union C. A union C. That means it's in A, or it's in C, or it's in both. Again, in ascending order, that's 3, 6, 9, 12, 15, and 18. Hopefully you got them. I'm pausing so that I can give you a chance to find them and not just take my word for it, but so that you can get used to finding it on this Venn diagram and working with these terms and symbols. Okay, and number 6 says A intersect C. So this means it's in A and it's in C. Intersect. A and in C. That's these 3 right here, isn't it? 6, 12, and 18. Okay, we're going to try one more example so that you kind of get a little more experience with intersections and unions on the next page. This is example D. Okay, and this is where, like I said, it really is helpful if you can write out the sets that you're talking about, because once we start getting into more complicated expressions like where A intersects the union of B and D, we're going to need to know exactly what sets we're talking about. Okay, so it does help to write out the elements of your set. Okay, so it says if D is the elements 2, 4, 6, 8, 10, 12, 14, 16, 18, list the elements of the following sets and display sets 1 and 2 using Venn diagrams. Okay, so going back to the previous page, when it says A here, this is talking about the A from the example on the previous page. So instead of flipping back and forth and trying to see what it is, let's just write what the elements in the set of A were. So A was the elements that were divisible by 3. So 3, 6, 9, 12, 15, 18. Okay. On set B, that was the elements that were divisible by 5. 5, 10, and 15. Okay. So now we know order of operations says that we have to do brackets first. So when you have an expression like this where you have A intersect something that is in brackets, always figure out your brackets first. Okay? So let's do that over here in the margin. Let's figure out what B union D is. What set is that? Okay? So B union D, that means the union means or, right? So this is where they're elements of set B or set D or both. Okay, so let's see. Elements of B or D. So here, B or D or both. Okay, so that would be 2, 4. We have to go in order. So next we jump up here to the 5, 6, 8, 10, 12, 14, 15, 16, and 18. Okay, this is the set B union D. Okay, now we need the intersection of A with this B union D. So it has to be an A and in B union D. Okay, well, let's check and see. If A starts with 3. Is that in this one? No. Okay, so it's not 3. What about 6? 6 is here. Yeah, it includes 6. Okay, what about 9? Nope. What about 12? Yes. What about 15? Yes. What about 18? Yes. Okay. So I wrote it down here. I guess they really wanted us to write it up here. So let's just transfer it up there. 6, 12, 15, and 18 are the elements that would be in the set where A intersects B union D. Okay. Now we have to label this on a Venn diagram. So we're going to do our A here, and this one is going to be our B union D. Okay, and in B union D, we've already figured out all of those elements right here. So we're going to just put those in here, but we have to remember any that are in both, in the intersection of A with B union D, have to go in this middle part right here, right? Okay, so let's start by putting those guys in there. So that would be 6, 12, 15, and 18. Okay? So we've already put those in their place, so we can put all the other ones. They are in just B union D. So that would be my 2, whoops, my 2, my 4, my 5, 8, 10, 14, 16. Okay, and which ones are in A only? Well, we've already done 6, 12, 15, 18. So 6, 12, 15, 18. So the ones that are in A only are 3 and 9. Okay? So don't let these bigger, more complicated ones intimidate you. Don't let them scare you. Just figure out the bracketed part first, then figure out the other part and put them together. Okay? So let's try this one. This one is saying the intersection where A intersects B and where that is united with or union D. Okay, so A intersect B is the part in brackets, so that's the part we're going to figure out first. So A intersect B. Okay, so intersect means it's in A and it's in B. So look back at our sets here. What elements are in A and in B? Oh, there's only one element that is in A and B, and that's the element 15. Okay, remember it is possible to have a set with only one element in it. So when we label this here, this is where A, it's in A and B, that's 15. Okay, now this is D. Okay, so when we have a statement like this, A intersect B, so that's the number 15, and then it says union D. So that means it's either in A intersect B, so it's either 15, or it's D, or it's both. Okay? So our set D is right here. We can label that on this Venn diagram right here. So that would be 2, 4, 6, 8, 10, 12, 14, 16, and 18. Okay, now this question is asking us for A intersect B, that's this circle, or D, that's this circle, or both. That's what union means, right? That's this one, or both. So really, in essence, it's this whole thing. It's all of those elements. That's our answer. But we have to put them in ascending order. So 2, 4, 6, 8, 10, 12, 14, 15. Don't forget that 15. We were counting nicely by twos, but that 15 is in A intersect B. 15, 16, and 18. Okay, so it's in this circle, or both. Okay, so it includes them all. Okay, this last one. Oh, they're getting really tricky here. They're saying we need the where the complement of A intersects the complement of B, and then we need the complement of all of that. Okay, what sets are we going to have to define first? We're going to have to know what the complement of A is. We're going to have to know what the complement of B is. And then we're going to have to see where they intersect and take the complement of that. Okay, so let's start with the complement of A, or A prime. Okay, that means everything that's in the universal set, but not in A. Okay, so look back here. Our universal set is natural numbers less than 20, okay? So D is not our universal set. Remember, our universal set came from the page before, natural numbers less than 20, okay? So we need natural numbers less than 20, but if it's in the complement of A, it means it's not going to be in A, okay? So that it's not 3, 6, 9, 12, 15, or 18, but it's all the other numbers that are natural numbers less than 20. Okay, so that would be the set of 1, 2, now not 3, not the multiples of 3, 4, 5, not 6, 7, 8, not 9, 10, 11, not 12, 13, 14, not 15, 16, 17, not 18, 19, and it's less than 20, not including 20. So that's where we end. Okay, the complement of B then. Let's see. B is, oh yes, multiples of 5. Natural numbers less than 20 that are multiples of 5. Okay, but again, B prime, or the complement of B, means all numbers that are part of the universal set that are not included in that, in B. So again, this would be 1, 2, 3, 4, now not 5, 6, 7, 8, 9, not 10, 11, 12, 13, 14, not 15, 16, 17, 18, 19. Okay. Now this question says we need to figure out what the intersection is, where A prime, this set, would intersect this set. Okay, so it would be in this set and in this set. That's what intersect means. Okay, so let's list what A prime intersect B prime would include. Okay, it would have to be in A prime and B prime. So 1 is in both, 2 is in both, not 3, 4 is in both, not 5, 6, 7 is in both, 8 is in both, 11's in both, 13's in both, 14's in both, 16's in both, 17's in both, 19's in both. Okay, now we're not done. We'd be done if the question just asked us to find where A prime intersected B prime. But now it says we need the complement of this whole thing. So, where A prime intersect B prime, the complement of that means it's not in this. It's in the universal set, but it's not in this. Okay, so what numbers would be left then that are in the universal set, but not in A prime intersect B prime? 1, 2, 3. I'm writing it up here where it gave us space to write it. Okay, so 1, 2, 3, 4, 5, 6, then we have 7, 8, 9, 10, we have 11, 12, 13, 14, 15, 16, 17, 18. And that would be our final answer. 3, 5, 6, 9, 10, 12, 15, and 18. Okay, so you see why you can't do these in your head. You can't just picture them in your head. You have to actually write them out because you're going to be getting some that are pretty complicated and you need to be able to see it in black and white. Okay, there is an assignment that you will be working on, so you'll get a chance to try some of these and practice these. And then we will be having a quiz on everything that we've learned in this unit. Circle logic, the logic puzzles that we've been doing, as well as this beginning set theory terms and intersections and unions. Our quiz will be on Monday, so you will want to spend some time over the weekend. You have tomorrow off school and then the whole weekend studying and making sure your homework is done so that you've had a chance to have lots of practice with these and you feel comfortable for the quiz on Monday.